17.1 Thermochemistry. Vocab. Thermochemistry is the study of energy changes that occur during chemical reactions and changes in state. Every substance has a certain amount of energy stored inside it. Chemical potential energy is the energy stored in the chemical bonds of a substance. The kinds of atoms and their arrangement in the substance determine the amount of energy stored in the substance. During a chemical reaction, a substance is transformed into another substance with a different amount of chemical potential energy. Heat, represented by Q, is energy that transfers from one object to another because of a temperature difference between them. One of the effects of adding heat to an object is an increase in its temperature. Once a match is ignited, it is a good example of heat. A system is anything that takes in or releases heat. It is also the part of the universe on which you focus your attention. A person exercising is a good example of a system because they are releasing heat. Another example of a system would be somebody sitting next to a campfire because they are taking in the heat. The surroundings include everything else in the universe. In thermochemical experiments, you can consider the region in the immediate vicinity of the system as the surroundings. The law of conservation of energy states that in any chemical or physical process, energy is neither created nor destroyed. If the energy of the system decreases during that process, the energy of the surroundings must increase by the same amount, so the total energy of the universe remains unchanged. An endothermic process is one that absorbs heat from the surroundings. In an endothermic process, the system gains heat as the surroundings cool down. In this example, it is endothermic because the heat goes into the system. An exothermic process is one that releases heat to its surroundings. In an exothermic process, the system loses heat as the surroundings heat up. This is an example of an exothermic process because the system loses heat to the surroundings. The sun heating up the earth is an example of both exothermic and endothermic processes. It is exothermic because the sun is giving off heat, and it is endothermic because the earth takes in the heat. The amount of heat needed to increase the temperature of an object exactly 1 degree Celsius is the heat capacity of that object. The heat capacity of an object depends on both its mass and its chemical composition. The specific heat capacity, or simply the specific heat of a substance, is the amount of heat it takes to raise the temperature of 1 gram of the substance 1 degree Celsius. The dietary calorie, written with a capital C, always refers to the energy in food. 1 dietary calorie is exactly equal to 1 kilocalorie, or 1,000 calories. The joule is the SI unit of energy. 1 joule of heat raises the temperature of 1 gram of pure water 0.2390 degrees Celsius. A calorie is defined as the quantity of heat needed to raise the temperature of 1 gram of pure water 1 degree Celsius. The word calorie is written with a small c except when referring to the energy contained in food. To calculate the specific heat, C, of a substance, you divide the heat input by the temperature change times the mass of the substance. In the equation, Q is heat and M is mass. Delta T is calculated from the equation delta T equals TF minus TI.